Okay. Alrighty, so let's get started. Alright, so today we're going to pick up on where we left off. So we finished on, well, we started talking about for loops, and mostly we talked about kind of the theoretical kind of examples with for looping, so just doing random for loops really. So today we're going to do a more practical example, which will be related to your project too. Your second project, that is. So your first project, that's due this upcoming Monday. And your second project, for the most part, it's going to be the same thing. I might add a few more things that you need to do on the second project, but basically it'll be the first project, but you're going to use for loops instead. And we'll talk about that in more depth next week. And so I know that there's some people that are struggling with the project. It seems like mostly with finding the indices for stuff. So I want to make sure that you guys look at the previous examples that we've done in class so far. So you can look at some of the lectures that we have, and then also look at some of the supplemental videos that I have too. So let me go to my channel. I guess I forgot to put the link for Monday's video on here, but it's on my YouTube channel. So there's some other videos that I've made. Let's go to our playlist. Alright, so there's other videos that I made for supplemental videos basically, so I guess here's one. So here we found the indices at one point. We actually did two different methods in this video. So you see here, I found the indices with kind of one of the first methods that we talked about in the class, which was using the find function with or in conjunction with a logical operator. And so this is kind of the first method that we talked about, and you can use this. Really, this code right here is extremely similar to code that you can use for the project. So for the project, you'd be saying like find when t, or whatever you call your table, t dot whatever column, so let's say county, is equal to county 1, county 2, etc. And that would be in reference to the top 5 most populous counties. So as this is set up, it's extremely similar to your project. You probably don't, I can't remember for sure, but you might not even need to use a cell array on the project, because the lengths for the indices for each county might be the same. But remember, we use a cell array if the length for each vector is different. Alright, so yeah, take a look at some of these videos. There's a lot of example scripts that we've done now in the class where we found indices for stuff, so you want to take a look at that. And that's the main part of the project, really, or that's the biggest hurdle, is finding those indices, and then you can basically use those indices to calculate or find basically everything else. And then you got a plot too. Alright, so the rolling average, there's a question, was the rolling average on the EGME video? Yeah, it was on the EGME video. Yeah, here. We also talked about it maybe in another video, like a lecture, but this video we use MovMean too. So remember, MovMean, that's only used to get the rolling average for stuff. So you see here in blue, this was day by day, and in red, that was when we used MovMean, and it kind of smooths out the curves. If you have large variations basically day by day, that's typically when it's used. And MovMean is really simple, right? We just say MovMean, we supply our data that we're going to run this function on, and then we add for our second argument how many days we want to use for that rolling average. So you would want to avoid hard coding if you want to change this later on. So in this case, or for our project, I think we use a rolling average of 7 days. Alright, so yeah, so take a look at all these videos and our lectures too, and you should really, we've covered, I think, literally everything that you need to use in the project. There might be really small things that we haven't covered. I can't remember for sure, but like sorting our table. You need to sort your table for the population spreadsheet by population, so you can get the top 5 most populous counties. And the only other thing I can think of that maybe we didn't cover, but I think we did one time, was the date string function, and I'm pretty sure that's in one of these supplemental videos too. So that would be if we're supplying the date, like in the title or something. So we've gone over the num to string function before, but if you want to print a date in your title, you would need to use the date string function. And again, I think that was talked about in one of these supplemental videos. Let's see if I put in a title here. Maybe not this one, but it's for sure in one of the videos. Alright, and then of course, if you need help, you can talk to me in Discord, or just go on the Project 1 channel. So I'm still a little surprised, and of course I'm not going to make you guys use it, but use the channel, right? You can help yourself out and help others out too if you have any questions. I'll turn on my light. Okay, and then your next quiz is on Monday also. So that'll be, you have your project due then also. So this quiz won't be super hard or anything like that. I'm thinking it'll be a kind of combo question of the if statement and the for loop. So it'll be something maybe similar to this, at least this kind of idea where we have to use both an if statement and a for loop in the same block of code. So basically you're going to have to loop through each element in some array, and based on like the value of that, you're going to print something out. So here in this question, we have to use both an if statement and a for loop. And so your quiz will be something similar to this. All right, question. Will we be deducted points if our date shows 3/20/2021? What do you mean would you be deducted points for that? You would maybe be deducted points if you hard-coded that. I want you to pull the actual date for the latest vaccination date from that column that you have for your vaccination data. And again, that would be like using the date string function. So you do something like date string, and then whatever your table might be called. So let's say t dot, I don't know what the column is called, but let's pretend it was called vaccine date. It's something different than that. So t dot vaccine date, and you'd want to get that last one. So you'd maybe do something like end. This exact code, it's not going to be the exact same here, but you'd want to get that most recent value. Yeah, so if it shows, I don't care, like if it's displayed as like, I'm just writing June, but whatever. Let's just say it was like June 21st, 2021. I don't care if it's like that, or if it's like 06/21/2021. I don't care how the actual date is formatted here. I should just be able to tell that, yeah, this is the month, this is the date and the year. Yeah. You can change the formatting for date time. It's something like you would have to, I think you need to first call the date time, and then you can add on an argument like input format, and then you could say like year, month, and then I think lowercase dd, something like that. You can look that up though. There's good documentation. Alright, so let's continue here. So I want to be sure that we can cover our practical example today so you can work on your homework, because the last question on the homework is doing a practical kind of problem. So we made a graph similar to this earlier on in the semester, and I think we only had like maybe 5 players then. And that's why you also only have 5 counties for your first project, because you have to type out like 5 lines of code for those 5 counties. And same thing with this. We had to type out 5 lines of code for each player. Or basically, a line of code for each player. But with the for loop, it doesn't matter how many players we have or how many counties we have. We can calculate something for all of them by using a for loop. So this is going to be good, or what we're going to go over today will help you with this, but also, even more importantly, it's going to help you with your second project. Alright, so before we do that, let's do a really quick review kind of example on a for loop. So remember, for a for loop, we say for our counter variable ranging, or let's say for our counter variable equal to 1 to something. So 1 will be where we start, and then the something will be where we end. So that's basically how many times we're going to loop. So in this example that we have here, we have for n equals 1 to 3. So that means we're going to have 3 loops. And then here we're calculating x, which is going to be equal to our counter squared. And we're also going to store all of the values in this example. So we're going to loop through the first time, and we're going to have x is going to be equal to 1 squared. And we're going to loop through again. So then our second value in our vector x is going to be equal to 2 squared. We're going to loop through one more time. And our third value in our vector x will be equal to 3 squared. So we get 9. And here you can see that this is going to be the final result that we have from our loop. And here you can see basically each pass. So the first pass we had x equals 1. Second pass we added on x equals 4. The third pass we added on x equals 9. Alright, so let's do just another little easy example. Let's say for k, our counter variable doesn't matter. We could say for bananas. So for bananas equals 1 to 5. And I'll do 1 to 4. Let's calculate x or something. Let's say x equals bananas squared. And then for every for statement that we have, we need to have an end statement as well. If we run this now, then you can see all of our loops here. Let me make this 1 to 3, just so it's easier to see it all. So we do banana squared. It's like the same example we have so far that we just talked about, but we have banana squared, that's 1 squared. Then we have bananas squared on our second pass, that's 2 squared. And then on our third pass, that's 3 squared. Let's add on another line here. So let's calculate y. And let's say y is equal to x plus 1. Alright, so now we're still calculating x for each pass. But once we calculate x in that same pass, now we're going to calculate y. So let's say for our first pass, remember x was equal to 1. Then we're going to go down and calculate y. So that's y equals 1 plus 1, so y equals 2. We'll go to our second pass. X is going to be equal to 4. Then we have y equals 4 plus 1, that's 5. We'll go to our third pass. X equals 9, then y equals 9 plus 1, that's 10. And let's say that I want to store all of the values only for y. So we could do y's of bananas. Okay, so this is going to tell MATLAB that I want to store all of the values, or basically all of the rows or the columns, whatever it might be, that we had for bananas. So now if I run this, you see that we are now storing all of those values, while before, all that was stored in our memory was the very last value. So, in the command window, because we didn't suppress our statement, it's showing us the value for each pass. But if I type in y in the command window, you see that y is only equal to 10. You can see that too in my workspace, which I forgot I took that out. Okay, here it is. We see that y is only equal to 10. It has the size of 1 by 1. Okay, but I want to store all of those values, so let's do y's of bananas. And now you're going to see that we have values of, what is it, 2, 5, and 10? Yeah, 2, 5, and 10. There we go. Also, you'll see here that we have a little red squiggly line, and this says that the variable y appears to change on every size of the loop iteration within our script. Consider pre-allocating for speed. We're going to talk about that today. We should be able to get to that. But, for our class, we don't really need to worry about this. Basically, if we pre-allocate our array size, that's going to save us, or it's going to make our code more efficient. Alrighty, so any questions before we get going on some new stuff? Okay. So the first thing that we are going to do before we start our practical example, let's take a look at this. So we can use for loops for plotting as well. So before, if we wanted to make this plot here, which is going to be what we work on today, if we wanted to make this plot here, we would need to basically write some code for each kind of group we have. So we have 4 things that we're plotting here: a four-seam fastball, a curveball, a slider, and a split finger. So we have 4 things, which means that we needed 4 lines of code to plot all of those. So this first one, we have scatter, which will make this scatter plot. So we have scatter, pitch RPM, and then pitch MPH. So that's just one group here. So that's just all of this red stuff up here. And then we had to do on a whole new line scatter of the next part, which is everything in blue right here. And then here's our third one, which is everything in cyan. And then our fourth one, which is everything in pink. So that's not, too bad, but imagine we wanted to plot, 20 of these kind of groups. That would suck. We would need to have 20 lines of code to do that. So we can use a for loop instead, and that can save us time. So yeah, we're going to do that, and let's see, I think I show you the code for that. Yeah, so here's actually all of the code that we're going to go over today, which seems very simplistic, right? But we're going to talk about everything in detail. So the code to make this previous plot here, it's in line 7 and 8. That's it. We're inside of a for loop here, but you see that we say scatter, pitch RPM, and pitch MPH. So in this previous line of code, or previous slide, we have pitch RPM and pitch MPH, but we have 4 kind of cells, right? Here, since we're looping 4 times, we're going to calculate pitch MPH and pitch RPM each time. And then we're going to plot one kind of group for each pass. So in one pass of our code, we're going to plot all of this. In another pass, we'll plot all of this. In another pass, plot all of this. And in the final pass, plot everything in light blue here. Alright, so that's going to save us time. And also you'll see that here I chose to not save the values for pitch MPH and pitch RPM. So we're also saving memory. If we don't need to have these values, then we don't need to save them all, but we can still plot them. Also in this line of code, I used a color map in MATLAB, so that's when we get these kind of pastel looking colors. We probably won't talk about color maps, but if you want to look at it, you can see how to use the color map. Here it's on this line of code, and then right here. Honestly, color maps, in my opinion, they're kind of a pain in the ass in MATLAB. I really hate it. So, I don't know. You can try it if you want. They kind of suck, though. Alright, so let's work on this example. I have the data up on Canvas. So it's for this week. If you didn't already download it, it's called Otani Data. So click on that, download it, make sure it's in the same folder that your script is going to be in. I've actually also seen from some of you that have... Yeah, second project is, remember, it's the same as the first project, basically, just doing for looping. I might add a few things that are going to be a little different than the first project, but by and large, it's going to be the same project, just with looping. Okay, so, what was I saying? Oh yeah, so I've noticed that some of you that have sent me questions, where your scripts are, they're still in that MATLAB schemer folder, which, I guess if you're fine with that, it's fine. But that's a really random place to have your scripts. So, hopefully you have a folder for college, right? And you have a folder for this class. Put your scripts in there so you can always remember where you have them. And I also made a video really early on in the semester now for how to move everything from that really random MATLAB schemer folder into a folder that's more logical, for college. Alright, let's close out of this. Make a new script. Okay. Say for loop. Also, you want to make sure that you always type in clear in CLC. Some of you don't do that every time, so a few reasons to do it. One, it just really clutters up your command window if you don't clear your memory and clear the command window. And two, if you have like, you see here, I still have all of these variables from my past script. If I want to run this script now, and I don't clear my memory in this line, all of those variables, they're still going to stay there in my workspace. So I want to clear all of those out so I only deal with the variables that we're going to define in this script. Alright, let's save this file now. Okay, so currently you see, I usually have a code just for code, so, or usually I have a folder just for code. This is a little messy, but currently my data sheet is not in this current script, right? So if I tried to import the data, I would get an error because my data is not in the same folder. So let me do that right now. Let's see, where did I store this? I made this script a while ago. You know what? Let's just go back over here and I'll show you guys what I would do. So I'm going to download this data from Canvas. Alright, and let's go to my folder. So we're in 205, we're in lectures, programming, and lecture. I'm going to go into my lecture folder, which I was just in MATLAB, but now I'm going to make a folder called code, or data actually. And I'm going to save this data sheet in that folder. Okay, let's go back over here. Let me close out of MATLAB for now. So let's go to my lectures. So you see I have this data folder that I just made. Oh, I already had it, I guess. Okay. Okay, so yeah, I guess I remembered wrong. So we're in programming, data, and the data sheet that you have on Canvas is called Otani Picture 0404. Oh, I was in here actually, that's why. Okay, so here's the data sheet that I just made. I'm going to make a new folder called code. And then I'm going to move the code file that I just made in MATLAB, which is this one here. I'm going to move that into my folder that's called code. Okay, so now I have two folders. I have code and I have data. Usually that's what I do in my, all of this is usually a lot neater. But let's go back to MATLAB now. Let's go over here. Hey. Alright, so we gotta go to Documents, Grad, Spring, 205, Lectures, Programming, Lecture. So my code is here, and my data is back a directory and then in a folder called code. So let's import our data. So let's call this table T, and we're gonna say read table. If your spreadsheet is in the same folder as your code, then all you have to do is type in Otani Picture 0404.csv. But for me, my data, actually this should be just like this. My data is not in the same folder, so if I try to run this right now, we're going to get an error. It says you can't find it. My data is back a folder, and then in a folder called data. So now if I run this, then now it actually imported, and you can see my table T is here in my workspace. Alright, so let me open up my script actually too. Forgot to do that. Where did I put that? I had it open before class. I should have kept it open. Okay, there we go. Alright, let's open up the workspace too. let's put that over here. I'm gonna go like that. And then I'll put this down over here. Alright. And I'm gonna move that like that. Okay, here we go. Finally ready. Alright, so did everyone import their spreadsheet? If you're following along too, or you can just watch too. Yeah, yeah. I mean, I'm guilty of being really disorganized too. If I look back on, well, I fixed it all now, but I know back in like my first few years for undergrad, all of my documents for college were just in the same folder for every class. That was terrible. So I always try to make folders for each class. Alright, so we imported our data, and now what we're going to do, we're going to convert a few columns to a string. So remember, we have to convert some columns from a cell array to a string array if we want to use logical operators at some point. So we have two things that we need to change here from a cell array to a string array. We've talked about this a few times now. One of them is player name, and then the other is going to be, what is it? Pitch name. I don't know where that is, doesn't matter. It's a cell array, we want to make it a string array, so I can use a logical operator equals later on. So let's do that. Plus conversions. Let's do t dot pitch name. That's going to be equal to a string, so we're going to convert that to a string. Get out. T dot pitch name. I'm going to go over this part fast just because we've done it before. Then we have t dot player name equals string of t dot player name. Okay, run that, runs fine. One more thing we gotta change is t dot description. We're gonna change that to string t dot description. Okay. Alright, so now what we're going to do is we're going to start our for loop now. So this is the whole big enchilada of the code. Yeah, what's up? Got a question? Jeez, results in a for loop. Yeah, so, okay, there's a question. How do we know exactly what we're going to convert? Basically, you know, a lot of the times I do this from the get-go, but basically, if you don't know, you can just try to run your code, and at some point, if you try to use like a logical operator, it's going to say that you can't run a logical operator with type cell. And it'll say that error in the command window. So if you see that, then you'll be like, oh, okay, I got to change this to a string then. A string if it's names, or words, basically. If it's a word like, let's go to one. So player name, this is for our player name. So those are words. We have to convert that to a string. But sometimes, like in one of our examples, we had a number here, launch speed. And I think at one time that was actually a cell array too. So these aren't words, right? So we don't want to convert it to a string. We'd want to convert it to a double, and that would be for a number. But for your project, I think you only need to convert some things to a string, not a double. But again, basically, I'll even comment these out for now, and you'll see later on it's going to say, hey, you can't run this operation on a cell array. Okay. So yeah, Lysandra said that for the project, it's just converting some things to strings. Okay, so let's do our for loop now. Yeah, didn't go too hard. That's good. Okay, so let's do for I. It can be anything. I just often use I, especially if you have an array. I would represent the rows, and then you could use a nested for loop, which we'll also talk about at some point, and J would represent the columns. Typically, by convention, it doesn't have to be like that though. Okay, so let's do for I equals 1, and this time I'm going to say length of pitch. I forgot to do some code up here. You're probably wondering what the hell is pitch. We didn't define that. So yeah, let's do that. I'm gonna go here and we're gonna say find unique pitches. Let's comment that out. Take this. Okay, so remember for our code here, we want to make this plot. So we have 4 pitch types. Again, if you don't like baseball, I mean, I get it, but we have 4 things we want to plot here, right? So there's 4 different pitch types. We have a 4-seam fastball, curveball, slider, and split finger. So we're going to use our unique function to find that. I could just hide this for now. Okay, so let's find those unique pitches. So I'm going to say pitch equals unique, and then we're going to reference our table, and then the column name is called pitch name. Now let's run this, and then in our command or in our workspace, why aren't you showing up? Oh, okay. I just didn't have enough width. Okay. So there we go. We have our pitches. And you see currently this is a cell array. Remember, I commented this out. So by default, for this specific spreadsheet, this column is a cell array. But now we have our 4 unique pitches. Alright, so let's go back to our for loop. Alright, the first thing we want to do is find our indices. So hint for your second project, right? You're going to have to find the indices for each county, and you're going to do that with a for loop for the second project. So let's make a little comment here, and let's say find indices for each pitch type. So again, we want to find the indices or the rows for when basically all of the rows for this 4-seam fastball, when that shows up in our table. And do t dot properties dot variable names equals pitch type. Oh, pitch name. What? Oh, I need to do it in quotes. Okay, 79. See, that you want to do that maybe sometimes, so 79, let's go here. So I want to find all of the rows when it says 4-seam fastball. So all of those indices. And then also for the slider, curveball, and split. Okay, so let's do that. So I'll call this pitch, int for pitch indices. And I don't care about storing all of these values. So I'm not going to store, basically each pass. I'm not going to store all of those results. So I'm not going to do pitch end of I. Also, this won't work because the amount of indices that we have for each pitch type, they're going to be different lengths. So remember, that's when we would use a cell array. So if I wanted to save everything, I would use curly brackets like that. But I don't care about storing all of those values, so I'm not going to store them. So let's do pitch indices, and now we're going to say t dot pitch name equals pitch of I. Okay. So again, this is similar to what we've been doing, for a lot of the semester now to find indices. I want to find when t dot pitch name, so I'm looking at this column. I want to find when that is equal to each unique pitch. So we just made this vector called pitch. So that contains 4 things here. And so on my first pass, I'm going to find when t.pitchName is equal to 4-seam fastball. So in my entire first pass, I'm going to loop through this entire column here, and I'm going to find when this is equal to 4-seam fastball. And in that first pass, we're going to get all of those indices. So I'm actually going to unsuppress it, and let's do, we're going to loop through pass by pass. Right now though, I should get an error because I'm using a logical operator and I have a cell array. So let's see. Yep. Alright, so this would be a big hint to you in the project if you see an error like this. So it says operator equals, that's our logical operator, is not supported for operands of type cell. So remember, currently, pitch name, that this column here, that was a cell array. And you can confirm that by typing in class of t.pitchName, and we see that's a cell. So let's convert that to a string. I'm going to go back up here. I'm going to uncomment that. All right, and then let's go back again, and let's start to go and look at this pass by pass. All right, so currently we're right here. You can see our little arrow. Oh yeah, again, to do this, what I did is I went over here. You can see a little dash there. I click right there, and that sets what's called a breakpoint in our script. So now if I click on run, it's going to take us automatically to that breakpoint. And you can see that we have more options now. So I'm going to click on step. And now it brings us to this line of code. And now it's going to calculate those pitch indices for our first pass. Oh yeah, also, so why did I put an I over here? So I want to iterate on for each unique pitch, right? We have 4 unique pitches. So on my first pass, I want to make sure that I look at just this 4-seam fastball. So I'm going to put pitch of I. All right, let's clear this out and let's continue. I'm going to click step. So here we go. We have all of our indices for when we have a fastball, a 4-seam fastball. And this is using a different method where we didn't say find. We're only using logical indexing. But if we want to be a little more visual, let's say find. Let's use find when t.pitchName is equal to pitch of I. Let's go out of here. Let's click run again. So now we're I exited out. I'm going to look at that first pass once again. Okay, so these are all of the indices for when we have a 4-seam fastball. So let's confirm this. We see 2, that's row 2. Look at that, we have a 4-seam fastball. We have that from 2 to 4. That's what we see here. And row 6, that's what we see. Row 12, that's what we see. All right, so that looks good. Let's continue looping. So I'm going to click on step again. And now we just calculated all of the indices for our second pitch type, which was a curveball. So let's confirm this now. You press step. Okay, so there's only 2 of them for a curveball. That's on 74 and 87. Let's check. 74, we have a curveball. 87, we have a curveball. Nice. Let's do step again. Click step. Now we have all of the indices for the third pitch type. That's a slider. Let's confirm that. Row 5, that's a slider. Row 8, slider. Looks good. We'll just do it one more time. Let's look at it for our last one, which is a split. We have a split on row 1, row 7, split as well. Alright, so it looks good, right? So compare this to our old methods. We would have needed to have 4 lines of code to find all of those indices. So 1 line of code for each pitch type. So this is saving us a lot of work already. Okay, so let's click on run. So the one thing that I want to kind of take of note again, let me suppress this, is that because I didn't save all of those values, the results in my workspace are only the results for that very last pass. So if I open this up on my workspace, this is, where's pitch IND? There. This is only just one vector, right? And it's saving all of the results for that last pass. So this is all of the indices for the split finger. But again, I don't care about saving that because we're actually going to we don't need to save those indices. They're not important to us. What we do care about, or what we might care about, is stuff like pitch MPH and pitch RPM, which we'll talk about in a second here. Alright, so next thing, let's find the amount of pitches per pitch type. So find amount of pitches per pitch type. So I'm going to delete this part. I'm not going to use the find function because we don't need that. Again, that's a little slower. We can just use this this right here. Also, this is nice when we use logical indexing because for each pass, the length is the same because we're running a logical operation. So we have 92 by 1, right? Because our table has 92 rows. And our logical operator is either going to tell us true or false, basically, for each row that we have. So remember, this is storing our last pass. So this is saying that for our last pitch type, a split finger, that for row 1, it's true that we had a split finger, which is what we saw. And then it's saying on row 2 that we didn't have a split finger. We see that's also true, that it was instead forcing fastball. Alright, so if I want to find the amount of pitches per pitch type, and we used a logical operator, all we have to do is use the sum function. So let's call this pitch n, and we'll set this equal to sum of pitch end. So really simple, right? So for this, again, I'll use the very last pass as an example here. This is going to sum up all of the true values that we have. And essentially, that's going to give us the amount of pitches that were thrown for a split finger. Alright, so if I run this now, you'll see that we had 17 split fingers that were thrown. And let's look at this pass by pass again. Why not? So let's click on run, and we'll step through. So for our first pitch type, that was forcing fastball, we had 52 of them. Let's go through again. The second one, our curveball, we had 2 of them. And that's what we saw with the indices, right? We remember for the indices for the curveball, we only had 2 rows. Let's go through again. For our third pitch type, we have 21 of them. And then for our fourth, we have 17. Alright, so exit out of that. For this, if you want, this would be easy to, we could store all of them. We don't need to, but I could say pitch n of I, run this now, and you see that we have all of those values here. Okay, but we don't need to store that. Also for our indices, let's go back there. Since we're using a logical operator, remember that we have 92 rows. So I should be able to save all of these too. Let's do colon, comma, I. So this means that we're always going to have 92 rows, and I'm going to have I columns, which corresponds to our counter, which really is 4. So let's run this, and there you go. For pitch indices, I now have 4 columns, and this corresponds to those 4 pitches. And we have the indices for all of them. Alright, but again, I don't care about saving that. We don't need that, so I'm going to delete that part. Okay, let's press this too. Alright, next part, we want to find the miles per hour. So basically we want to find how fast each pitch was thrown. Alright, so let's call this pitch mph. And now we are going to look back at our table. So let's do find when t dot properties dot variable names. I hate typing that out, it's so long. Equals release speed. Release speed. Wow, okay, column 3. Alright, here we are. I'm just doing that just so I can show you guys when we confirm that our calculations were done correctly. Alright, so let's find how fast each pitch was thrown. So we're going to do this group by group again, because remember we have 4 passes, which corresponds to our 4 pitches. Okay, so let's do pitch and ph. This is going to be equal to t dot release speed. So that's this third column here. We want to find the value for that. using our indices. So we're going to be using array addressing. Alright, so for your project, this is why it's so important to have found those indices, right? We found the indices here. We're using them again here, and we're going to be using them again right here. So we're using array addressing for our third column here with the pitch indices that we found. So on our first pass, what this code is going to do is look at in this column, and it's going to use array addressing for our first pitch type. So it's going to give us the speed for each pitch that was thrown for a four-seam fastball. Alright, so let's check this out. We'll do pass by pass again. So click run. Let's see. Actually, yeah, this should be okay. Okay, so let's go here. There we go. Let's go to our first value. There's a lot of four-seam fastballs. So let's look at our when did we have our first four-seam fastball? According to our indices here, that was on row 2. Oh geez. Okay, yeah, 79. So it's row 2, that was when we had our first four-seam fastball. And then if we go back to row 3, let's confirm that that was a value of 100.9 thrown heat. And if we confirm that with what we just calculated, that says 100.9. So that looks good as well. Okay, let's go through one more. So our second pass, that corresponded to a curveball. Our indices, so the first time we had a curveball was row 74. Let's check that. Row 74. Let's go back over here. Pitch name for 74. That was a curveball. That looks good. And from what we just calculated, that says that it had a speed of 75.5. Go back to column 3. And we see that that's true. We had a value of 75.5. So it looks like our for loop is still running good. Alright, and then we have one more thing that we have to calculate here. Go out of that. Which is going to be the RPM. So I know this part is, hopefully so far, even if you don't watch baseball, you know what's going on, right? It's just how fast the ball was thrown. For this one, we're going to say how spinny a ball was. It's just, so we're finding the RPM, how many revolutions per minute a ball had when it was released. Okay. So for this, let's find when this showed up. Release spin. That was, that was called release spin. Released, spin rate. Okay, column 57. Alright, there we are. Alright, so let's do it pass by pass. Let's do it just for the first pass. So let's do it for our four-seam fastball. Let's click run. We're going to step through. Oh, I gotta tap my code first. That would help. So pitch, RPM. We're going to say T dot release spin rate. And we're going to be using our indices once again. So, very, very similar to what we just did with the release speed. We're just changing this for the spin rate now. Okay, let's step through it now. Let me suppress that line of code. Run, step through. Alright, so pitch RPM. Let's step. Alright, so our first value is 2417. That was for our four-seam fastball. Remember, the first index, or the first row, when we had a four-seam fastball was row 2. And what we just calculated says that that value was 2,417. And let's confirm that. We go to row 2. That's a value of 2,417. Alright, so it looks like we are good. So now we've calculated everything that we want to calculate for our graph. What we're going to do now is also make our plot within our for loop. So I'm doing this, I'm doing it inside of our for loop here because I am not saving all of these values. So because I'm not saving all of the values, if I was outside of the for loop and I wanted to make my plot, I only have the values for that last pass, remember? So if we don't want to save all the values, but we still want to make a plot, we can do that within our for loop, and that's going to make our plot pass by pass. So on our first pass, we're going to have a plot that's just for a four-seam fastball. Second pass will then add in to that same plot, the plot for curveballs, and then sliders, and then the split finger. So let's make a comment and call this plot. And we're going to use the scatter function. Okay, we're not making a line plot, we're doing a scatter plot. And we'll say pitch. Actually, let's do pitch MPH on the x-axis. And then on the y-axis, we'll do pitch RPM. Alright, let's do it loop by loop once again. Also, we're going to add in the argument of filled, so our circles are solid. If we don't have this argument, they're like hollow. So let's go pass by pass again. Alright, so now we should see our plot generate. There we go. So this is a scatter plot for all of our four-seam fastballs. So on the x-axis we have the velocity, and we're going to add a label later on. And on the y-axis we have the spin rate. Alright, so let's continue here. And I actually didn't do this before step by step, so I'm interested if this is going to also change our axis limits when we're kind of stepping through for each pass. Let's see. Okay, it didn't. Oh, I forgot to do something. Maybe that's why. So currently, that's a good thing. So you saw that it overwrote our plot. We don't want it to do that though. We want to add on to our plot. So we have to type in hold on. Alright, and I think for our for looping, when we make a plot inside of our for loop, we only say hold on. We don't say hold off. Okay. So let's step through again. Okay, so here's our first pass. Let's continue stepping through. And there we go. Okay, cool. So now in our second pass, the scatter plot for the curveball was added. Let's go to our third pass now. And now all of the values for the slider were added. And let's continue on to our fourth pass. And now all of the values for the split finger were added. And you also see that because we're going pass by pass and we have our for loop in here, MATLAB also knows to make each pass for what it's plotting a different color too. So that's really convenient for us. Alright, and then we're gonna, if I continue to press step, then you see that eventually it's gonna show a down arrow, which means that we finished with our for loop. Alright, so at this point we want to add in our labels. So we don't need to do that inside of the for loop. We can actually still be outside of the for loop, and we can add in all of those properties. So let's just say plot parameters. I'm going to do this quick because you guys know how to do this. I'm going to do it just really rough here. Alright, so let's do X label. This is velocity, MPH. Y label, spin rate, RPM, and then let's do our legend. So we actually made a value up here called pitch, which is for our unique pitches. So I can call that here. So I'll just say legend, and then we'll say pitch. And let's put this legend in the northwest. Let's run our code again. Oh, dang it. Let me take that breakpoint out. Now let's run our code. And you see, let's run it again. Okay, now this is updated for our plot. Let's make that actually this legend in the southwest. Also, you see here, so our colors changed because I kept the figure open, but it ran the loop again, so it changed the colors, but our legend colors stayed the same because that's out of the loop. So if you want them to be consistent, you got to close your figure, then run the entire script again, and then all of the colors are going to be consistent. Alright, so there we go. You know what, let's quickly add on the date string function just because I see that's in my code here, and maybe, I don't know again if I ever talked about that before, so let's do title, and we're going to say Shohei Ohtani on, and now we're going to use our date string function, so I want to call the date for what this data is for, and in our table, that should be in the beginning, yep, we have a column called game date. So this is for one game, so every single row is going to be the same. So if I want to put this in my title, I just need to get one of these rows, right? Because they're all the same. So let's say date string of t dot game date, that's the column name, and let's get that first value, because again, it doesn't matter which value I pull, they're all the same. So do game date of 1. And let's close this out. There we go. Run it like this. And there we go. We have our title using the date string function. Alright, so that's how we would make this. So are there any questions on the for looping part? Let's scroll back up here.
So you know how you find the indices, right? So you don't have to do that for every pitch type. You need to go for one.
Yeah, so for the indices, I didn't have to, have like 4 lines of code for each pitch type because it's looping for the pitch type over here when we have pitch of I. It's looping for those 4 values that you see here.
Thank you.
Alright, and then question, do we have to use date string on the project? Yeah, you do. In the deliverables, I don't know if I tell you it has to be in the title, but I think I specified that you need to show the most recent date of vaccinations somewhere on your plot. Let's check it out. Oh, I just saw it. Okay, the most recent day should be, for testing should be, I shouldn't say testing, that was from last semester. The most recent day for vaccinations, that should be included and that should be in the title, like you see. Oops, don't do what I did on these other two, but yeah, you see they should be in the title for all of your figures, so I should have put them in my title for these two. Okay, your plot doesn't show up. Do you need to use the figure function? For this figure, for this code that we just went over, it doesn't show up? If you're in a whole new script, you shouldn't have to, but I've noticed that if I'm in a script where I have multiple figures and I use that figure function, then each figure has to have it. So yeah, you could say like, okay, yeah, so it worked then. Yeah, so you might need to type in figure 1 or something like that, and then it should work. Alright, so if there's no questions on this, then we're going to continue on with the lecture. So if hopefully, you guys could follow along with this, but this might be something where you want to look at the video again, and especially just get practice in on your own, whether that's with the homework, or even, you're not restricted to everything we go over in this class. You could do anything on your own too, and you would really start to gain a lot of experience, or you would learn a lot that way. But if there's no more questions, then we're going to continue on. Alright, so initializing arrays. We're going to talk about nested for loops too, probably next class. I don't know. I don't think, well, we might get to it today. So let's talk about initializing arrays. So let's go here. So for the same code that we have, if I type in I, so let's say that I want to save all of the values that I have for all of the pitch indices. So let's say I wanted to have, like we saw earlier on, I want to have 4 columns for the pitch indices. So that means column 1 would be all of the indices for our first pitch type, column 2 for the second pitch type, and so on. So if I wanted to do that, I could do that. So I could do colon comma I. So I think this would give us an error. Yeah. So if I just say pitch int of I, that's going to give us an error because MATLAB sees this and it thinks, oh, I want to make just a 4x1 vector or a 1x4 vector. I just want to have 4 values in there. But really, we want to have 4 columns. And with those columns, they're going to have a ton of rows. We don't need to specify how many rows. So we could just say colon, then comma I. And what does this say? Okay, let me comment some of this stuff out. Oh, okay, yeah. So let's just do it for what we want to look at here, just to make my point. Okay, so let's run this now. Missing the end statement. Okay, there we go. Okay, so if I put colon, that just tells MATLAB however many rows that we have, save all of those rows. So if I open this up now for pitch ind, then you see that we have 4 columns and we have 92 rows. And remember, so if I just put pitch of I, that's telling MATLAB that I just want to have 4 values, and really we're calculating more than 4 values, so we're going to get an error if we run this. So when you use for looping, if you want to save all of the values, you really need to make sure that you know exactly what the size is that you want to save. So here, if we want to save all of them, just do colon comma I. We save all of the rows, and then we have I columns. Okay. Alright, so yeah, let's go back here. So you see that currently I have a red squiggly line here. And if I hover over the error message, or it's really a warning message, it says that the variable pitch ind appears to change in size on every loop iteration within our script. And then it says consider pre-allocating for speed. So to show you what's really happening here, let's unsuppress this, and we're going to loop through pass by pass again. So once I go on my first pass, we have all of these values. So we have 1 column. And then if I go to the second pass, then it adds on a column. So it's appending a column. Go to my third pass, it appends another column. Fourth pass, it appends another column. So this is growing in size. And because of that, that computationally is expensive, meaning that it requires a lot of resources to do that. So it's going to make our script run slower. Now for the size of data that we have, it's not really going to be an issue. But if you have a really huge data set, you would want to avoid this. So you would want to pre-allocate the size, like that warning message said. And basically what that means is that we are going to specify the size for what we're going to calculate in our for loop beforehand. So this is either called pre-allocating an array, or most often, at least from my experience, it's called initializing an array. So let's make a comment here called initializing an array, or say arrays. Okay, and then to initialize an array, we can either use the zeros function or the ones function. So we talked about those really early on in the semester, but usually we use the zeros function, and that'll make an array that's just full of zeros. So let's do pitch ind and we're going to set this equal to zeros. And now we're going to say, we're going to do the height of our table, which is called t. So for tables, you can't use the length function. You need to use either height or width. So basically, I want to get the length for how many rows we have. So for that, I'm going to use height. So if I go in my command window and I type in height of t, we see we have an answer of 92. And remember, that's that's how many indices we're going to have. So 92 rows. Okay, so I'm going to do height of t. And then we have 4 different pitches, right? So remember, in our loop, we looped 4 times because we have 4 different unique pitches. So here I can type in length of pitch, and that's going to be 4. So if I go here just to show you length of pitch, that's 4. So, we're doing this again so we don't hard code. If something was going to change, like the amount of unique pitches, if that changed later on to, let's say, like 5, if we had hard coded 4, well, now, at this later point in time, you would have to change that manually by yourself. That's a pain. You want to avoid hard coding. So if I just type in a length of pitch, and again, at some point later on, if our new spreadsheet updated to 5 unique pitches, we won't even have to change anything in this entire script. Alright, so let's comment. Actually, let me just run this part here. Well, it's going to run it all. That's okay. Actually, yeah, I do want to comment everything out. So let's comment all this stuff out. Okay, if I run my script, only up to this point. If I look at pitch IND right now, this is an array that's 92 by 4, and it's just full of zeros. That's it. So we've predetermined, or we've pre-allocated the size for this array. So now if we loop pass by pass again, so let's go back in our for loop here. So first off, you see that we don't have that red squiggly line anymore because we have pre-allocated the size. So if we go pass by pass again, okay, so watch when I press step here, we're going to fill in our first column, but we're also going to see that we have the 3 other columns. So you see here, we just calculated this column, and we've already pre-allocated the size for this array. So you see that the other 3 columns are currently full of zeros. If I go to the second pass, we're going to fill in the second column. There we go. You can see it. Because it's a logical result for our indices, they're only going to be 1s and 0s. And that would also be a reason why we used the zeros function. If I used the 1s function, well, that would be implying that we have, indices everywhere. That would not be ideal. Let's press step again, and now we added in 1s for our 3rd column. And then we go to our 4th pass, and then we do that for our 4th pass. We get the indices. Alright, so that's why you would do that. This is something that you'll probably see, I don't know, somewhat often. Because again, they are very useful to make your script more efficient and not be computationally expensive. Alright, any question on that part? Okay, so we're going to finish off today on nested for loops. So basically you'll get a little sneak preview of this, and then we'll talk about it again next time. Okay, so let's let me uncomment this stuff. And I'm just going to comment this out just for now. Alright. Make a new section here. Let's call it nested for loops. Alright, so we can use nested for loops as well. So you're going to see nested for loops used most often for something like an array, but you can use it for other things too. Of course, I had a good example before class started in my head and I forgot it, but they're not always used for arrays. They can be used for different things too. If you want to kind of break stuff down a bit more, I'll try to think of a more practical example, so we can go over that next time. But what you would, I guess, most often see it used for is when you have arrays. So if you want to like find when some value is met in an array, you kind of want to go row by row and column by column. So because you want to go row by row and column by column, you would use a nested for loop. So we can make this matrix here with a nested for loop. So we're going to have for I equals 1 to 4, and below that, we're going to have for j equals 1 to 4. So for us, we're going to say that I, that's going to represent our rows, and j is going to represent the columns. But we can call this whatever we want. We could have for p equals 1 to 4, and for, I don't know, like q equals 1 to 4. And then that could be like p is going to be the rows, and q, that could be the columns. Alright, so let's make this array here. So we're going to say for I equals 1 to 4, because we have 4 rows. And then we'll say for j equals 1 to 4, because we have 4 columns. And now we're going to add in an if statement. So we're going to say if I, which is going to represent our rows, if that is equal to 1, let's first say if I equals 1, or if I equals 4, oops, double equal sign. So if we're on the first row, or if we're on the fourth row, or if our first column is 1, or if our column is the fourth column, then we're going to make those, we're going to say a of I comma j, we're going to make those values a value of 2. So this is saying if we have, if we're in the first row, or if we're in the fourth row, or the first column, or the fourth column, we're going to make that a value of 2. So this means a of I comma j, that's our row, and this is our column. We're going to make that a value of 2. Okay, and then if that is not met, then we're going to say make that value a value of 1. So if we're not in the first row, or the fourth row, or the first column, or the fourth column, we're going to make that a value of 1. Okay, so we need to end out our if statement, and then we got to close out our for statements as well. Now I can run this, and oops, I typed something wrong somewhere. This should be our fourth row should be full of 2s. What did I type wrong? It's probably a small thing. Oh, did we define? No, we didn't define a before. What am I not seeing here? I don't know. Oh, well, we're out of time now, but we'll pick up on this next time, because I'm not seeing some issue right now. But we can run this code, and what should happen is we should get this matrix to show up where we have 2s in the first row, in the fourth row, in the first column, in the fourth column, and then for any of the values that aren't met for that, we're going to have 1. So in that case, it would be, oh, in the center. I think I know why. Let's type in A. Yeah, there it is. I was only looking at this output here. That's why. So there we go. It did run correctly. Alright, so we're going to talk about this, go over this example again in more depth on next class. Alright, so out of time. Hopefully that practical for loop example helped today for your homework and your project. Your first project due next Monday, so it's really coming up. And we're also going to assign project 2 next week as well. And your quiz is also on next Monday. It'll be similar to the homework. It'll be a combo of a for loop and the if statement. Alright, so I'll see you guys then. Have a good week and good luck on the project.